Okay, I'd say it's working, except we're not live today. Hi, Ben, even though you're not live. Well, you're live now, but we're not
We're
live.
alive. We are alive.
Alive. I like that.
At the time of recording, at least.
Yes.
Hey,
Yes.
Bill.
So our electrons flow to the right and the positrons to the left on our Feynman diagrams. So I wanted to apologize. I have been slammed with work and double booked on my Fridays. So we are doing a pre-recorded show today, but it's a good one. Ben, what are we talking about today?
Well, you had this great idea, and it's actually an evergreen topic because people constantly fight with this. But we're going to talk about PCB CAD and footprints because everyone gets frustrated as heck with these things, right?
Right.
And you're working on your network stuff, which has been taking you away from our regular live time, but you are still also an active contract engineer. You've been designing hardware lately, as have I a little bit. Oh, look at that. You've got some paste stencils in frames.
Yes, because when we talk about footprints, we're going to talk about, and I got the idea from you, what all we're generating with footprints data, right?
Yeah.
But the data gets used by various steps of the thing. Everything from the PC board creation to, in this case, how to put solder mask on the board to assemble it.
Yeah, and actually, this is why people run into trouble, I guess, and why this is a good topic, because there's standards out there, of course, and a lot of people don't follow them. Most people don't most of the time. Even people who are aware of the standards.
Right.
Usually don't follow them. Not really.
Though some really smart people have really good reasons for not following some standards, I have noticed.
Yeah.
But they're the people with the X-ray machines.
That does come up. There's always there's rules and there's always exceptions to the rule, and that's what being an engineer means. Really, it means knowing when the rules can be and should be broken and when you should obey them. But yeah, I mean, so when let me start by this though. When I say the word footprint, what do you think of?
Well, I do think of something like this. I think of the thing that I interact with on the CAD. And already on this one shot here, there's various pieces of information that are worth talking about and having you tell us about each part of it.
Right. So and describing really quickly, like an English paragraph, like you could look over my shoulder. I could be working in the library editor and you'd be saying, oh, what's that footprint for? So like you have that immediate recognition of what this is.
Right.
Being a hardware engineer, you know what this is. And the interesting thing about that, just a bit of psychology there, it wouldn't matter what CAD I was using. If you were looking over my shoulder and I was in KiCad and placing pads around in an array, you'd know, like, oh, you're making a footprint. What's it for?
Right.
So to me, I'd say at the bare minimum, people think of a footprint as the two-dimensional macro that allows all the pads of a component to be soldered to a board. And at a bare minimum, and that's in the 3D view.
You said 2D, so it made me think 3D. Yeah.
At a bare minimum, it's the copper pads that are exposed on the board that have to be able to have the component pins or balls if it's a BGA, or lands if it's a land grid array or a similar part, to be soldered to. Right, but from way back in the day, those were called. Hopefully, the noise of my air conditioning.
No, I don't hear it.
It's really now loud vent above my head. It's distracting.
Yeah, I'm running mine too. I'm just drenched here.
I'll try and ignore it. But if I go back in time, before we had CAD, these were little decals that you could peel and stick that came on plastic sheets.
Rapid Ready Type or Rapid Proto or something.
Right,
Yeah, there was names for it.
Somewhere pressure sensitive, like you'd lay it over
And
your
burnish it.
Mylar film and you'd rub it and it would press it on.
Right.
So before there was CAD, there was little template things that we would use to either illustrate them with a marker pen on the Mylar film, or those press and peel or peel and stick decals. So if you look at Mentor Graphics, pads and other tools that were like from the first generation of CAD, Altium is among the first generation of CAD because it originated as Protel, and it was also launched as a product right around the same time that OrCAD and pads were.
Okay.
Just from a different part of the world. And I don't know why Protel or Nick Martin, when he made Protel, the first version, called them footprints. I think in Australia at the time, people just called those decals footprints.
Yeah.
Because it's the footprint of the component. And there was no standard. There was no... So anyway, just a bit of history there. But people call them different things. So if you meet with a seasoned PCB designer and they call it decal, you know, that person spent a lot of time. Yeah. That person spent a lot of time using pads from Mentor Graphics.
Right.
And if they call them footprint, they probably came from the Protel / Altium world. I think OrCAD may have also called them footprints when OrCAD had a PCB tool, but they got smushed into Cadence. So I don't know what the language of, I think it's the same. But if you read the standards, so there are standards for these by IPC. So if you look at the IPC 2220, IPC, that's the 2220 series. So IPC 2221 and IPC 2222. And then there's specific standards for land patterns. IPC SM782 was the original surface mount component standard for designing the 2D representation of surface mount parts. And by the way, these standards don't dictate the name per se,
right,
of the component package type. So here's an interesting thing we all do, and it's a bad habit, but it's actually not a bad habit because we all do it and we all know what we're talking about. If I look at a footprint in the library or whatever, I might call it a SOIC 8 or SOIC 8.
Right.
Because it's an 8-pin SOIC, which stands for Small Outline Integrated Circuit. Well, the SOIC 8 name doesn't come from the IPC land pattern standards.
Right.
It comes from the JEDEC package standard.
Okay.
So there's two different things here. We have the 2D land pattern, and I'm now using the actual standard language for it. So we have that, which is what you just showed me in your footprint editors, the 2D macro of what gets put onto the board image for the layer that the component's going to be mounted to. But then JEDEC, which is a completely different organization, but they kind of work somewhat in partnership. JEDEC is a joint, I forget what the acronym is, but it's an electronics industry, and it's more focused on the actual semiconductor manufacturers. So they produce standards for the actual semiconductors and their packaging.
Okay.
So the package is the actual physical molding around the chip and the lead frame, and the way the pins are bent and clipped to make a gull wing SOIC package, right, for example, or a flip chip BGA or something like that.
Right.
Like they define all that stuff.
Looks like JEDEC means Japan Electronic Data Interchange Council. Do I have the right JEDEC?
JEDEC.org.
JEDEC.
No, EC. JEDEC. JEDEC. The nice thing about JEDEC is, I don't know how they're funded, but they're well funded enough that if you sign up for a free personal membership, all the standards that pertain to printed circuit layout, like component physical packaging and lead frame stuff, all those standards are freely downloadable, whereas IPC, you got to pay for the standards.
Right. Joint Electron Device Engineering Council.
That's it.
Yes.
That's the one.
Not Japan.
So JEDEC defines packages, among other things. They also define memory standards. So when there's a new generation of DDR coming out, so they're working on DDR6 now. DDR5 is reasonably well defined, but it's JEDEC who brings all the different RAM manufacturers together, and they all have a lot of meetings and argue with each other for months and months and solve the problems and decide how fast. But they're the ones who say, this is how fast this next generation of DDR is going to go. This is going to be, okay, to get that speed, what do we need to be able to do to make it go that fast reliably, and how do we test it, and what are the problems? So they're the ones who define those standards as well. But it's funny because we always refer to the 2D PCB footprints by the same naming that they use.
Right.
But why? Here's the thing: like back when boards were 2-layer through-hole and CAD was new, what did you need to make a footprint? You just needed pads,
right?
In an array, and the whole point of having a footprint in a library is you're not manually placing each little thing, which is a pain in the butt. You're dealing with standard packages, standard arrays, standard distancing, and grid placement. So what it meant was it was essentially a collection of your macros that you could reuse. So it's the first element of reuse is your library. And back then, even mass-produced electronics, there was no solder paste. There were wave soldering,
drag and wave solder,
and the board would go over a solder wave,
right?
And so, what did you need? You needed solder mask, you needed the actual copper pads, and you needed that in a fixed array. And we didn't have 3D, so it was like super simple. The bare minimum in a footprint is just an array of pads, and that, from the IPC standards, technically we refer to that as the land pattern.
Okay.
The land pattern. The land is the pad on the PCB, where the pin goes through it or sits on it or whatever, and it lands there, and that's where the solder is deposited. And so, if you want to get real technically the right language, according to IPC standards, it's a land pattern. And so the other standard, I mentioned 3 others. There's design standards, so 2221, 2222. The original surface mount standard was called IPC SM782, and that defined like the first generation of things like chip resistors, when we thought an 0805 was tiny.
Yeah.
And we're like, this is terrible. We won't be able to hand build anything anymore.
Right.
Everything's has to be made by machines now. How funny that is. So 782, and then there's a more modern standard that started. It's still not that new, but probably 10 years ago or so, more than 10 years ago, they came out with the 7351 series standard. IPC 7351 defines, and it keeps getting updated every few years, but that defines the standard of how footprints should be designed in your CAD library so that they're very reliable and contain the information necessary. What's really annoying about it is it's impossible for a standard like that to deal with anything that's kind of CAD specific. Right. And there's too many different CADs. There's KiCad, Altium, pads, Expedition, Allegro, whatever. There's
Right.
countless CADs out there. And the thing is, most of them, because the most popular ones grew from an era when a lot of these things weren't needed, then it wasn't strictly defined how this data should be added to your footprint. So if you show your screen again, and we think again, what is actually needed to manufacture a board? That's the mindset you need to have.
Right.
And the bare minimum we see here in what you've got pads, which is the red is the top copper for those who don't use Altium. You may have different color schemes in your whatever KiCad or whatever CAD you might use, but top copper is red. But we see the purple outline there. So because we may have wave soldering, do you need to grab that?
Yeah. Bill Hurd. Hey, Tony. You actually caught me on a call. Yep, about 45 minutes. All right. All right, sorry about that. That was at 16:20. If you do need to edit that. Go ahead.
Yep. I can probably edit this. So we see this. The pads have. So what was I saying? We think about what's actually needed to make a board now is very different than what was needed 30 years ago when everything was just 2-layer through hole. Even then, we had solder mask because of the wave soldering machine.
Right.
At least on the bottom side of the board, which was
right.
The
it was so
side.
expensive that we would, and it would take an additional couple days that for prototypes we'd order our boards without solder mask.
Yep, but that was okay because for prototypes, articles, everything was hand soldered.
Right.
And so, and if you had big enough clearances and you designed the board well, like intentionally for it, you could also design a board to go through a wave solder without solder mask.
Right.
And solder would stick to all the tracks, but if you had big enough clearances, they wouldn't bridge. But it was risky.
Right.
But I've seen power supplies and audio power amplifiers where they deliberately did it that way to add solder to the copper on the board where they had big wide traces for heavy current. So
they're tinning the copper basically.
Basically, yeah. So but all of that is critical to the footprint. So you at least need your copper land pattern that the pads get soldered, the component leads are soldered to. And you, at very least, those have to have solder mask openings. And so that's what we're looking at with the purple outline there. But you have also silkscreen.
Right. The yellow in this case.
That doesn't mean it's yellow on the board. You tell the manufacturer what color ink you want and all that when you're ordering your boards. But the silkscreen is kind of an interesting one, and it leaves a lot of room for personal taste because it's about what the board's going to look like when you make it. And why do you even need silkscreen?
Right.
Why do we need silkscreen?
Well, that pin 1 dot, and that's a conversation to have because in my footprint here, or this in my footprint, but in this footprint, I can't move that dot on demand. I have to move it for every use of the footprint or create a footprint with a different dot. But from having Chris Denny on the other week, he was saying on prototype builds, give us pin 1, something to indicate pin 1.
Yeah.
So it is very important for the non-automated, even the automated setup.
Right. Well, there's two. That's two reasons. So one is, again, silkscreen was only needed because we had
humans.
The first pick and place machines were people, and they needed to see orientations of parts and reference designators of parts on the board in front of them on the assembly line. And even today, most products have some kind of human interaction on the assembly line. It's possible to design something that needs no touch, and there are manufacturers like Sierra and Chris's company, Worthington, that have an
Right.
option if you really narrow down your design to meet this very specific set of rules and part types and sizes. You can have a no-touch assembly process where it's completely automated.
Right.
But you even still need silkscreen then for two other reasons. One is serviceability. So if you're looking at a board and you need to replace a part, you've got to be able to identify where it is and all that.
Right.
But the other is automated optical inspection, OAI. Is that what it's called? Or AOI.
AOI.
Chris calls it AOI. So it's automated optical inspection. Yeah, AOI. So they have a machine at the end that takes a photograph, and it's basically
you train it, right?
Simply put, it's actually a machine learning application where you get your 5 first article prototypes that have been assembled and tested, and you know that they work flawlessly, and they've got all the right parts that are from your actual bill of materials. You put them in the machine, and it takes photos of them, and it does basic 2D graphical training on the photos, and then everything that comes out of the reflow and test at the end. Actually, before it goes to flying probe test, usually, or to electrical test, it goes into the AOI machine. It takes a photo, and if any component doesn't look like it's supposed to look, according to the training set, it flags it as an error and puts an image on the monitor attached to the computer on the machine with red circles and things and notes about what looks wrong. So if you have a component that's mounted correctly, but the printing on the top of the component doesn't match the training set,
right?
It can say, "Oh, the part number, the optical character recognition says the part number is the same, but the ink looks different." In other words, this could be a counterfeit component.
I never thought of it that way. I always thought of it as upside down component or wrong.
Could be upside down. Could be, or the other one, the more frequent thing is the component's billboarded or tombstoned or has head in pillow.
Right.
And it'll flag all of those. It'll flag all of those things. And so that's AOI. But
right. So we were talking about silkscreen. So and what Chris was talking about and what I've experienced is when you get like a tube of LEDs, identifying which one is pin 1, or I'm sorry, even a tape reel. Pin 1, the computer has to know which side is pin 1, so related to the pin 1 you specify on the PCB. Yeah. And most of the time, everybody says pin 1's the ground, the cathode, but does it ship with pin 1 to the left or to the right in the tape? That becomes the.
And this is why the data sheets. This is why the data sheets have a packaging page, kind of as a suffix.
Right.
And it shows how, like, if you order this part with the tape and reel order number, this is how they come off the tape. Like, they give you that information.
I've seen data sheets that don't, but they should. Yes. And
there are some where they leave that off. They assume that the only person reading the data sheet is the design engineer, and they don't care how it's packaged.
Yeah.
But they do. Those manufacturers that don't do that, they often provide that as a separate document that sort of applies to all the parts they ship that they manufacture, and you can download it. And some just don't provide it, and you have to work it out, which is a pain in the butt.
Right.
So we know we need some silkscreen.
Which used to be actual screening, right? But now it's ink. It's basically ink jetted onto the board. Is that correct?
As far as any factory I've used in recent times, yes, it's basically an inkjet printer, and actually even the solder mask is now pretty much done that way. It is developed optically, like it's like the copper is.
Yeah.
But it's sprayed onto the board as a liquid. That's why it's called LPI, liquid photo imageable.
Oh, that's so cool. So what are these other, so that's our solder mask. So let's talk about the purple.
That's your solder mask.
I'm sorry, I meant, silk screen. So the purple, the solder mask. So when I make a component like this, here's what's different for me with Altium is I don't have a good way to measure these pads. So when I make a part myself, it's all about the pad properties. But I'm used to being able to come in here and measure this with like lots of small rulers. And in Altium, the default ruler is huge, so you got to go in and make it small. I just don't get to use it. I have to do it by counting dots as opposed to using rulers when I use Altium.
Yeah,
not so with Proteus.
Again, it depends on which CAD you're using, but there's different ways you can make sure things are in the right. So you're talking about the land pattern now and getting it exactly dimensionally right. So there's the size, but you can also. So if I have to create a footprint that's some kind of new package, it's unique.
Right.
The first thing I'll do is say, well, they're going to use a certain specific XY spacing, and I can make a grid. You can make a grid, and this is the easiest approach, honestly. You just set the grid in the footprint editor when you're first placing the pads, and you make the grid exactly so that they'll snap to exactly where they should be, and then you know they're there. That's the simplest
right. That's
thing.
the Altium way to do it, and that's how I've had to do it.
Well, I would do that in any CAD. Like, I think all CADs can do it that way, which is why it's a good approach. I could do it the same way, I think, even in KiCad. But if you place them and you want to measure it, but if you place them and you want to make sure they're correct, there's a reports menu there. Go back into your reports menu.
Okay, yeah, I was going to show a typical footprint that you get in the data sheet here in a second.
Okay, so with nothing selected in your properties panel, right, you see the snap options section, which is under your selection filter, the top half of the properties.
All right, so I can't see well, and we've been through this before, but
these are the items that.
So you want the grid menu, right?
No, hold on, don't change the grid. Go to the snap options in your properties panel. This is where you control what you're going to snap to. So this is important because if you grab a pad, you want the mouse cursor to snap right to the center of the pad.
Right.
Right? Or to whatever the reference point, because you can have offset pad centers. But this will see how pad centers is checked.
I use this. Yeah.
So normally the default settings there are just fine. So once you've done that, if you go to the reports menu at the top, and there's measure distance and measure primitives. So, and Control M is the shortcut for measure distance. So now that'll snap to the center of a pad. So go over a pad. So you snap there, you click, and then you go, and this gives you the exact pin to pin spacing.
All right.
In that direction.
Now, if I want to do this clearance between these two, I have to go pad edges.
You hit escape, and you don't. No.
All right.
No, don't need to do that. Just go back to reports. Measure primitives. That's the difference. Primitives will give you the spacing between them.
Ah.
So it's 0.27 millimeters.
Right.
Yeah. Copper to copper.
Okay, I learned something. I sat here and tried to use all the various visual measuring methods and ended up having to use snap grids and just knowing where the grids are.
So see, that's the difference. Like, there's two approaches to designing something. One is to kind of get it visually looking right, and then move things around until you know they're right. But that's iterative and slow. I'm not saying you were doing it that way. You weren't. You're doing it the smart way, which is you set the grid, and then they're all on grid. But it just means you have to keep going and changing the grid as you go.
Right.
So, but there's other data that's needed to make a full footprint. And what's frustrating as heck to me is there's designs and libraries done by all sorts of different people. Like, we all want to download something nowadays because it takes time to make good footprints, and people don't like actually doing, unless I've met people who just love doing libraries and that's all they want to do. They just want to be a CAD librarian, and they're happy doing that. And it's not really, you don't qualify as a electrical engineer.
No, I think it takes
librarian, but like it's a comfortable, satisfying job for some people I've met.
Right.
It's all they want to do. You don't need to be an engineer to do it. You just need to know how to use the software and be
I think it takes a village to make
standards.
I think it takes a village to make a footprint. You know, I think it takes input from various people. And on one show we were talking where somebody said, "Oh, the person that did the bad footprint should be whipped and flogged," you know. And to me, it's like, well, no, it's everybody needs to contribute to the PCB guy, the engineer. Everybody has some ownership of the footprint because we all want something out of it.
Everyone involved in the hardware design has some responsibility to notice if something's wrong.
Right. Hey, how do I get these reports off the screen now? It's showing the center to center.
Shift C. No, I don't know what you did there. Could you go back to the footprint?
Yeah, hang on.
It's to the left. That right there. Click in the workspace first, so it's got focus. Then do Shift C.
All right. Oh, so just clear the filter.
It's clear the filter.
Okay.
It's the same command as if you're highlighting or whatever.
Which is an important command in Altium.
Yeah. So, you know, that's how you can make sure things are in the right spot.
Yeah, no, I love it.
But what I was going to say is also irritating is, so we want to be able to get footprints, and there's a lot of different places. There's different libraries. You can download open source reference designs from the part manufacturers. You can use the libraries that come with your CAD, and all of them, it doesn't matter where you get them from. If you didn't make everything of yours from scratch to your own standard, they're all going to have some differences which become irritating somewhere along the line. There's no avoiding it. So it's really cool that there are services like SnapEDA where it's like, I'm working on a design. I don't have time to make this library component. You know, it's a
well, for me,
it's a complex thing. So I don't want to do it. It's got, like, you look at some of those new MOSFETs from TI and Infineon that are basically, the silicon has some copper pads on it and a metal can, and the whole thing has to get mounted directly to the board in a really obscure land grid array that isn't any kind of doesn't need any kind of standard packaging. It's totally unique, and it requires really odd shaped pads and solder paste deposit, and it's super time consuming. So the first thing, what are you going to do? You're going to look for a CAD model that you can download, and this is why there was a business opportunity, and companies like SnapEDA actually even exist in the first place.
Right.
Any PCB design specialist, and I'm talking about dedicated PCB designers, layout people who aren't necessarily electrical engineers, but they've had a career in just laying out boards, who are, let's say, 50 and older in age, that I've spoken to, says, I never use footprints made by other people, which is a lie. What they really mean is, I will take something, but I will spend the time making sure it's correct and modifying it to meet my library standard.
Right.
Because, and you have to do that, because it'll bite you in the butt if you just use things verbatim you can probably get away with it for several boards if you're just making, if you're a hobbyist and you're making boards for your own projects, no problem. But if you're trying to get something ready for actual factory production, large scale production, it will bite you in the butt.
Right.
So,
right.
Because they don't, there's no standard for, or there has to be a layer named paste mask. And that layer has to have, like, there are IPC standards where it will give some guidance as to how solder paste should be added to footprint pads, but they don't dictate how the CAD library should be.
Right. Right.
And the, well, I'm talking about solder paste, right? Solder paste has to get on those pads so that the component can be then put on that, and then the whole thing can go through reflow, and it's exactly the right amount of solder in the right place. So when it melts and reflows, you get a good attachment. And that's what you're showing there. So there's a top paste layer. So the
right.
CAD will have, in the footprint library, will have specific layers for different things. But what annoys me is most CADs, for all the additional data that you still need for manufacturing, especially for large scale manufacturing, there's no standard to follow as to what those things should be called or where they are.
Does Altium auto-generate paste if it's missing a paste for a pad, a specific, the footprint was made without a paste mask layer? It seems to me that Altium generates that from the copper and then does a shrink.
It's automatic. It's automatic. Solder mask and paste mask are automatic because, and this is important because this can actually catch you by surprise as well. I just recently was testing some prototype boards that I've been involved with a project on, and there were some big open pads on the back of the board that are part of a footprint for attaching another device to separately from the soldering and reflow. But we forgot to check in those footprints that they had the default solder paste, so they had solder deposited onto them.
Right.
And we actually didn't want that necessarily. It's okay because we're just in a science phase of development.
It was a DNP problem, right? It basically the pads of a do not populate.
Yeah, they still had solder paste at the assembler.
Right.
They still had solder paste mask openings, so they got solder paste on them, and then it went through reflow, and so there's this kind of meniscus.
You're right. You end up with little mounds. Yeah.
Which is, it really isn't a problem for what we're working on, but it's like, okay, if this were a mass-produced product and this part had to be added separately later on, and we don't want solder there.
Solder already there.
We want whatever is just the direct copper interface with whatever preservative is on it.
I'll ask you then. So let's say I have some DNP components, do not populate, on my board, and I want to block the solder mask, the paste from landing on those pads. What do you do?
Well, the only way to do that is to, there's actually two ways. The one simple way to do that is to actually, you have to close the solder paste mask in the footprint. So you have to know you have to be able to do this. You have to know how to do this. So if you wanted that pad one right in front of you there, you could select that
but
pad.
Let me stop you. I apologize, but let me stop you. The problem, I can't do it to the footprint because they'll do it to every 0603 resistor. So I need to do it on just R1.
That's if you're reusing that. So you can then override it on the actual board.
Right.
In that variant. The problem is, I think, if you override it on the board and you have different design variants where some parts are populated or not, it's not a per variant thing. You're overriding it for all of them. So that is not very good.
All right. So is there a good answer?
Yeah, so you can actually select an individual pad here and modify that individual pad's properties, even though it's part of a footprint.
And
they're
there's
read
the face
only.
mask
They're read.
rule. Yeah.
They're read only. So what you so they're read only. So
Okay.
here you'd have to unlock that pad from its parent component.
Yeah, I'm looking for the little lock that goes with it.
It's in the component, so you have to click on the component first.
I don't know what that means, Ben.
Click over the actual component pad.
Oh, back
Not
on the
pad,
screen.
but the actual whole
Right,
component.
back on the screen. I thought you
now
meant
you
in the
click.
menu.
Now you have to click the primitives lock icon.
Got it.
So that means you can move the pads individually and totally break the whole thing apart. But
very good.
So the only other way, and I haven't actually tried this, so I don't know how well it'll work, but you should be able to say in design rules, because solder mask and paste mask openings are driven by design rules. So you can go into design rules and say, for this particular component, create a custom mask rule. Yep. So you can go paste mask expansion, and you create a new paste mask expansion rule. And in the new rule, yeah.
Oh, hang on.
Yep. And in there, you set the query to say for a specific.
Well, that's wrong. That's footprint. But for a specific.
Whoops. Well, it would be, because it's like for that particular part.
There's what I was looking for.
Yeah, you can go for component and say, well, for this one, okay, we're going to say don't use paste. So they've improved this rule. This used to only have a dimension, and you had to make it negative so it would close in towards the center of the pad.
Okay.
Because it was a negative. The masks are a negative, right? So by giving us a checkbox, they saved a lot of people much time and brain power. They've made that. That's actually a pretty good improvement that's been added to the tool.
Very cool. Very cool.
So you need the pads, the actual copper land pattern. They have to be identified. And here's the other thing. Sometimes you have the same signal connecting to multiple pads in a footprint. Let's say you're doing a MOSFET in a SOIC 8 package.
Right.
You're going to have 8 pads on the board, but one of them's a gate, 3 of them are a source, and 4 of them are a drain. That's a pretty typical SOIC 8 MOSFET.
Okay.
And there's 2 schools of thought as to how this should be done. And the traditional stodgy school is you still must number the pads 1 through 8. And then you have to have 8 pins in your schematic symbol to match up to those 8 pads.
Right.
And,
yeah, I'm from the days.
I hate that because then you have to draw the symbol such that you recognize that internally these are actually all connected to each other.
Right. I'm from the days when the pad on the bottom would cause all kinds of problems in the early days, and now it's given a number. It's number 17 or 36 or one more.
Oh, you actually
show it on the schematic.
That's your heatsink pad, right?
You're right.
With a QFN. So all those, I still number those in the footprint.
So do
but
I.
I don't have an exact matching symbol. I prefer to use a standard IEEE 315 compliant symbol that shows a MOSFET with a package, like a circle around it, and three pins named S, D, and G. And then you use pin mapping in the component editor. So you have to be careful, and it takes a little effort, but I only have to do this once and everything works perfectly. So I have pin mapping, and I can map multiple pads on the footprint to 1 pin in the schematic. That's how I I much prefer to do it that way.
Okay.
If I'm using a reference design by TI or someone else, and they've done it the other way where they have exactly 1 pin per pad and they're exactly numbered, so they don't have to do pin mapping, the tool will automatically map by number at first. So if they've done it that way, I'm not going to go modify. I'm not going to go changing their reference design. If I'm using that as a basis for my own board, I'll leave it how it is just to save time. But
so the solder mask then was done, the purple here was done as a
That's
rule, an expansion. Right?
Yeah, and you know, you mentioned Chris Denny. He was on the stream with you when I couldn't join a few weeks ago. I asked Chris this question years ago, as from an assembly house's perspective. I have this problem. I don't necessarily know ahead of time how thick my solder paste stencil is going to be. There's different standard thicknesses of solder paste stencil.
5 mil, 3 mil. Yeah.
Yeah. Hold that. Could you hold that up real close?
Absolutely. It's worth showing.
And solo. I want to solo you on that one. Wait, how do I? There it is. Hold that up real close to the camera. So this is a solder paste mask. It's in a welded frame. It's tensioned.
You can see it's epoxy to tensioned. It's stretched. Yes.
Yeah, you could use it like a drum. Only I wouldn't do that because you don't want to dent it.
This is old. Yeah, it's old and dirty.
You could see the holes in that, the openings. Right. So that's how solder paste, and that goes into a machine, and the machine presses a stainless steel squeegee down on that, and squeegees paste, which is microscopic beads of solder, right?
Right.
And it's got a particular thickness, and the assembly factory wants a specific amount of solder on the pads so that when it goes through reflow, you get like the exact right heat adhesion and a good solder fillet that with no voids.
Right.
So all of that, you know, you'd think today, okay, well, we could actually calculate the volume, and you could even model you could simulate using fluid. You could
dynamics. Yeah.
You could actually, like, if you had SolidWorks with the full simulation extension, or Autodesk Inventor with its full simulation add-on that does fluid flow, you could actually simulate solder paste reflow where it's melting and then moving through surface tension into a nice fillet. That stuff could be modeled, but all of this was developed before we had simulation software that could do that stuff.
Right.
So the entire industry and all the standards are not based on scientific numerical methods. They're based on, this is what works because we've tested it a million times, and this is what we came to. This is the best. So, but you don't know exactly the thickness of your stencil necessarily. Like if you own them like you do, Bill, there with yours that you've got over there, you would know.
Right.
But you can basically, what does all that mean? It means designers want to ask, well, how big should my solder paste openings be? And the answer is your assembler will worry about that. Now, if you're making your own prototypes and you're using OSH stencils, you just showed me a
polyamide one. Yeah,
I use those too for. They're pretty good if you're only making, say, less than 10 boards.
This was needed because this is on the opposite side of a board that cannot be held levelly in a stencil holder. So I had to hold it in a tall vise, because it's got tall components. And actually, the other one is trimmed to fit flat, so I can go in and do it, because there's just no way to get a flat thing and still hold the board flat easily by the edges. I mean, it has to be really flat for that stencil.
Yeah, you need a good flat surface. So if you're doing prototyping, it's a bit different.
So these are fine if you want to hold them by hand and squeegee them on.
Yeah.
They wear out earlier, but that's not a concern in prototype. You wouldn't use these
really
in production.
Thick. They're really thick. So
I have 5 and 3 mil because this connector, I didn't want it to build up solder too much, and I wasn't familiar with how my rework solder paste worked. So I ordered this in 3 mil and 5 mil thickness, and the 5 mil works just fine.
Yep. So if that's the rule there. If you're doing stuff by hand for your hobby or prototyping, you need to experiment and
Yeah.
try different thicknesses.
And that's what I
you
do.
can
I do
easily
fast
end up
turn
with too much.
prototyping.
Yeah, if you're doing 0402 parts, you can easily have way too much solder paste.
Yep.
And I've used the polyimide, like what you just held up, for down to 0402, and it was borderline too much solder paste.
Right.
I didn't think ahead. So here's the thing. If you talk to Chris Denny, because you're going to Worthington Assembly, he says, we'll change it. We will change your solder paste mask openings, and you won't know. We will modify it because we know how much solder we want on your board.
So
for our
I
process.
want to know how to take his changes. And that was kind of the impetus behind today. If we know what Chris knows, how can we modify our footprints to be the perfect 0402 footprint in Altium?
You ask, you say, like, if you get a prototype done by them and that's what you pay for too, is they'll update your CAM files that you send them. You can ask them to send you their final CAM files, send you a copy.
Right, and it's up to you to figure out what they did.
But the golden rule, he said to me, and other assembly houses have said to me, is just set your, okay, so there's a solder mask is set as, in the design rules, I don't know if you want to show this, solder mask is set as an offset from the pad edge.
All right.
And the paste mark is, so that's going outwards from the pad. Let's have a look at that. Can you show that?
Well, I'm doing the design rule check. That's what you said, right?
No. Cancel that.
All right.
And go into design rules.
Oh, I'm sorry. I hit design rule check.
Rules.
Yeah. Sorry.
Yeah. And go into paste mask. You go to solder mask expansion first and look at the solder mask expansion rule. And you see it's from the pad edge outwards.
Right.
And this is important, and you may need to customize this if you're doing things like really fine pitched BGAs and you need solder mask defined pads. Your pad may actually be larger, and so this number can be negative. You can make this or check the box that says solder mask from the whole edge.
Okay.
This is interesting because that applies only to through-hole pads, and they're not always going to be. You can also say, create a rule here if you don't want your vias exposed. If you want your vias covered, which most of the time I do.
Right.
You need to create a rule here that says, for vias, you set the query if you set the query to say if it's in a pad class, or do custom query and type is via. Right, and then check the tented box. The tented box.
Oh, I'm sorry.
So what that means, your vias are going to be covered with solder mask. So you can't actually use them as test points. They're going to be completely covered. But that way you can have silkscreen over them, and the manufacturer won't complain that you've got silkscreen over bare copper, because they don't like that.
Right.
So anyway.
Which is another, that's one of the things that is not a default in the design rules, is to check for silkscreen on bare copper, but it's a checkbox, so you just go in and check it. I don't remember.
It does check that. It does check those manufacturing rules. But now go to paste mask expansion rule, and you'll see that one goes from the, and it's hard to see the little arrows on this.
Right, but they're at 0 millimeter right now. I mean, it's saying no expansion, which is a little strange.
That's the default. And the reason is assembly manufacturers who actually do the pasting and the soldering and reflow all say the same thing. They say just leave your solder paste mask the paste mask openings to be matching the pad. And then they may make adjustments to it. And they may make adjustments to some pads on the board, but not others.
Right.
But then we have a problem with parts like QFNs, where there's a heatsink pad underneath. One big fat heatsink pad, you're going to get way too much copper on it. Way too much solder on it.
Right.
So you have to go into the footprint and make like a windowed paste. Like you have to manually create a paste mask that is like an array of solder paste openings to put less solder on the big open heatsink pad.
Have you
and
ever
then you have
seen
this other problem? If you put a heatsink pad, you're going to want to put vias in it, and the vias will wick all the solder away to the other side of the board. So those have to be covered. So the way I used to do it was I'd manually place an array of vias in the footprint itself.
Right.
I'd have tenting on the vias, and then a custom array of other little blocks for solder paste. So it would be such a pain. But now the wizard does all of that stuff for you.
Got it. Are the shapes ever non-rectangular? Have you ever seen hourglass shapes where they go in and cut out the centers?
Yeah, I've seen shapes that look like a baseball base.
Okay.
Yeah, it's like a flag, kind of a flag shape, where it's partly rectangle, partly triangle. I've seen that a lot, especially for parts in older boards when we were still using MILFs. A MILF is a little cylindrical part, but instead of axial leads, they just have butt ends, and they get surface mounted. MILFs are a pain in the butt, and people don't much use them anymore. I think you can still buy parts in MILF, but not much, because they had a habit of being difficult for pick and place machines to pick up because they have a curved surface, and they also have a habit of, when being dropped onto the board, rolling off. That kind of old surface mount technology, and not very good.
So I've seen where they'll add a little piece of Kapton tape to like the top of a micro USB connector, so
it's got a flat surface to suck on.
Right.
I've seen that. Yeah.
So we're coming up to. Unfortunately, I'm going to have to jump here in a few minutes, but in the next 4 minutes, how can we summarize what we? Oh, let me show one thing here real quick. Let's see if I can. I have to share, and it's more just me complaining about something. That's not what I wanted. Anyways, when they show the pads, they don't do all the math for you. I really do.
No, I hate this too. I wish, because so that was something that I loved about working in a mechanical CAD and Fusion 360. It's not entirely there in the PCB side, but they're actually doing it. It's any field that's numerical, you should be able to enter a formula or expression into. And that's something that the mechanical CAD companies really got right early on, is everything's parametric, and so you can actually this is what I hate about data sheets. They'll give you the information enough to make the footprint, but their way of referencing it all sucks.
It's being a little familiar with how tolerances add up. Sometimes these don't make sense to me, because these aren't all from the same edge. For example, like the distance in the middle, they don't show you the height of these pads. You have to go in and mathematically figure that out. And so our PCB guy was one of the main calculator users back in the old days, because he'd have to sit there and do all that. Now I use the spreadsheet.
Because by default in CAD, every pad, its reference is the very center of the pad, not
which isn't even shown here.
I just hate this.
I do too.
Every time I get a data sheet like this, I want to wring the neck of the person who did this package design, the company.
Right.
But what can I do about it?
Right. So,
and
well,
this
hey, Ben,
is why Altium and others, but especially Altium, and you guys need to get on top of this, because even Upverter, before they killed it and turned it into a different thing that it isn't, when Upverter was an actual web-based, stream-based PCB design editor, it had its quirks and it was pretty limited in what it could do. But one thing that it did from the get-go, architecturally built from the ground up to do, was mathematics in any field.
Right.
I could type in the formula. And guys, I'm talking to Altium and anyone else who does CAD, take it a step further, make the whole thing, give it a parameter table in the software that can be referenced by anything in the design, a parameter table for the document and a parameter table for the project level. And I'm not just talking like Altium has parameters, has a parameter
that I can never get to work. Yeah.
That's text. I'm talking about mathematics.
Values. Yeah.
You need something like, and this is why people say, who come from the high-end tools that cost a lot more money, like Cadence, if they go from Cadence to using Altium, their first thing is there's no constraints manager here. Right. Well, that's not true. The rule system in Altium is actually extremely powerful. It's just different than other CADs, and you need to learn how to use it. Once you know how to use it, you'll actually love it because it's very efficient workflow-wise in many ways. But one thing that was missing was that whole spreadsheet way of operating. And I'm not suggesting it should be Excel embedded into Altium. I'm suggesting make it like mechanical CAD tools like Fusion 360, Inventor, SolidWorks, all the 3D mechanical tools on the planet have this concept of parametric modeling, which means you can have a list of parameters that are named and they can contain formulas and they can reference other parameters, and you can put any kind of regular mathematical expression into them. You can use trigonometry. You can, like, it's a game changer. You specify everything and you put in your base dimensions, and you can basically put in base dimensions, and if everything else is already done, all your sketches and everything are already done, referencing your parameter table, it automatically rebuilds the whole thing according to your base dimensions.
Right.
So I could make an entire motor vehicle and have it all boiled down. Like if I really wanted to, I could have it all boiled down to one thing, the length of the car or the scale length. And I could make it a full-size car, or I could make a copy of that assembly file, right? It would be a pretty big file or set of files on disk. And then set the base dimension to be 3 inches. And now I have my scale model, and it's exactly the same, just smaller. So,
well, hey, I have a hard stop. I got to jump, but it was great talking with you today. My apologies again for missing a couple weeks. And my apologies for this not being a live show. We'll get back to doing those because I really enjoy them on YouTube, Ben. So, all right. Excellent. It was good talking with you, and we see you next week.
Okay. Thanks, Bill.
Yep. Thank you.